Hi, Richard here from Past That Science. A little quick one today on power factor. Lots of definitions and stuff on power factor. If you want to know more about power factor, then check out the video of a more detailed description on power factor. But this one's going to be a short one, a couple of examples on how to determine power factor for a couple of different circuits. So there's lots of definitions of power factor. One of the definitions is that it's the ratio of the circuit resistance and the circuit impedance. And what that means, we can boil that down into a formula, R over Z. Power factor is R resistance over Z, the impedance. Now if we use an example that we had before, here's our power triangle with the resistance value of 24 ohms, and using Pythagoras theorem we determined that the impedance was 31.24 ohms. So power factor is R over Z, so that our R is 24 and the Z is 31.24. So we take 24 divided by the 31.24 and it gives us 0.77. So that's our answer, that's our power factor, 0.77. Give it a little sense check. Power factor is always going to be a number between 1 and 0. So we're looking for something, a number between 1 and 0. Does our figure fall into that category region? Yes, it does. 0.77 is between 1 and 0. If you got the formula wrong, you would end up with a number greater than 1. So you know that that's not right. So that's what you're looking for, a number between 1 and 0. So that must be correct. Now for a little different example, here we're going to use a different definition of power factor. Power factor is defined as the ratio of the circuit's true power, P in watts, and the apparent power, S, that's in volts-amps. You may recall that we've used a power triangle before that has P and S. Well, power factor is P over S, true power over the apparent power. So here's an example then. I have a power triangle that has a power value, true power value of 3 kilowatts, and we also have an apparent power of 3.23 kVA or kilovolt amps. So then if our formula is P over S, true power over apparent power, then that's going to be 3 kilowatts divided by 3.23 kilovolt amps. I haven't bothered expanding it out into the thousands because it still come out with the same answer. You can do it that way. So 3 divided by 3.23 gives us 0.93. That's the answer then. Power factor is 0.93. Again, let's sense check it. Power factor has to be a number between 1 and 0. Is our answer between that region, between 1 and 0? Yes, it is. It's 0.93. So difficulty would be remembering the formula. So R over Z and P over S. R over Z is resistance divided by the impedance. P over S, true power divided by the apparent power. Okay. Now go past that science.